So for examples, we go through the report writing for experiment 1, so just have a double check. So your carbon resistor will have a value of 100 kilo ohm. The carbon resistor we use that day is 100 kilo ohm. Then you have to record the maximum current. So the uncertainties for the maximum current will be 2 microampere, the smaller scale for the microammeter we use, but then might consider up to half of the smaller scale, okay, whereby you consider the pointer to the half of the smaller scale. So you might also write your uncertainty to half of smallest division, 1 microampere. So both is accepted. Then the voltage we connect that day is around 4 volts. The theoretical value of the capacitance of capacitor C1s we use is 560 microfarads. That one is the theoretical value for capacitor C1. So double check the uncertainty, you can write 2 microampere. So because the smallest divisions is 2, so all the reading for current there will be no decimal places. Then the time recorded can read up to 0.01 second. So the T1 recorded, T2 and also the T average can put up to 2 decimal place. Follow the uncertainties for the time. Okay. Same goes for the second observation table. The theoretical value of capacitance of capacitor C2 that we use is 1000 microfarads. Okay. So since we connect the C1 and C2 parallel for the second experiment, so the C effective, the theoretical value for the effective capacitance will be C1 plus C2. So it will be 560 plus 1000. So the theoretical value for the effective capacitance for observation 2, the second part of the experiment, will be 1560 microfarads. So again, the uncertainty for current will be 2 microampere. Then the time will be recorded up to 2 decimal place, 0.01 second is the uncertainty. You need to calculate the centroid. Then you are going to plot the graph ln I0 over I against T. So for the graph plotted, make sure you have the title of the graph. Then you label the y-axis and also the x-axis. So plot the centroid on the graph and make sure all the point is plotted correctly. Then you are going to calculate the gradient of the graph. So just double check because our gradient is y over x. So the unit for the gradient should be second minus 1. Okay. Then by comparing the equations with the straight line equations, so we are going to have the gradient will represent 1 over time constant. So we are going to determine the time constant from the gradient of the graph. So you might calculate the time constant. So the time constant will be 1 over gradient. So you will get the unit for time constant is second. So double check, make sure the unit for gradient and time constant is correct in your report writing. Then you are going to calculate the capacitance of capacitor C1 using equation 1.1. So equation 1.1 is time constant equal to RC1. So we might calculate the C1 by taking the value of time constant we calculate from the gradient, divide by the value of R. So the value of R is 100 kilo ohm. So 100 kilo ohm is 100 to the power of 3. So you will get the value of capacitance C1. Then you need to compare the value of C1 you obtained from the experiment with the theory value. The theory value will be 560 microfarad. So micro means negative 6 farads. Okay, so compare with this experiment value. So calculate the percentage difference. Then same goes for the second observation data. You are going to calculate the centroid. Then you are going to plot the graph I0 over I prime against T prime. So again, you are going to calculate the gradient of the graph. So don't forget to put the unit for the gradient. So it's second minus 1. And then by comparing the equations, we find out that the gradient will be 1 over time constant. So we can calculate the time constant for two capacitor connect in parallel. So make sure the unit for the time constant is in second. Then you calculate the effective capacitance of the capacitor. So the C effective will be our time constant calculated divided by the resistance. So again, the value of resistance is 100 kilo ohm, kilo times 10 power of 3. Okay, then for the C effective you calculate, so you compare with the theoretical value. So theoretical value for the effective capacitance for the two capacitor connect in parallel is 1560 microfarad times 10 negative 6. So you are going to compare this theory value with the experiment value that you calculate. Okay, then under the discussion, make sure by referring to the percentage of difference, you need to state whether your experiment is success or not. So if your percentage difference is less than 15%, then you might consider your experiment success. Okay, then so you can write down the precautions that we already discussed during the demonstration of the experiment. So like what is stated in under the procedure, one of the precautions is before we start or repeating the experiment, we have to make sure the capacitor are fully discharged by short-circuiting the capacitor. So this is the first precaution step. The second one, since we are going to store charge in the capacitor before we discharge it, so we have to ensure that the leg of the capacitor in connection are not touching each other. Otherwise, the capacitor will not able to store charge. Okay. Then basically for all electrical connections, when we perform electric experiment, we have to ensure all the connections are tightened and secure. This one is to avoid unsteady readings due to the loose connection. Then another extra precautions that you might put in is we have to ensure that the circuit is disconnected from the power source when we're making changes. So make sure you doesn't on any power supply when you make changes to your circuit. This one is very important in order to protect both of the individual that work on the circuit and also the component itself. So setiap kali kalau kita nak lakukan sebarang perubahan kepada litar eksperimen kita kena make sure kita disconnect daripada power supply dulu. Okay, so ini adalah langkah keselamatan yang patut kita take note, especially bila kita melakukan eksperimen yang berkaitan dengan elektrik. Okay, so this is the precaution step that you might put under your report writing. So you might pause the video and then note down the precautions. Experiment value that you obtain for the value of C1 and also the effective capacitance when you connect two capacitor in series is a big difference from the standard or theoretical value. This is might due to some errors that we make during we perform the experiment. This might due to some random and systematic errors that occurs when we perform the experiment. So we need to write down the source of error that might leads to the inaccurate of our reading obtained. So one of the source of error is the parallax error when we read the scale on the microammeter, because our eye is being positioned at an angle to the pointer. So means that your eye is not exactly perpendicular to the scale. So how we are going to minimize or eliminate the parallax error? One of the suggestion is you might replace this kind of analog microammeter with the digital microammeter. So bila anda gunakan jenis yang digital, so it means that you tak akan ada masalah parallax error. Okay, so if we still are using the analog microammeter, maybe some of you akan tulis yang ni sebagai precautions untuk overcome parallax error, whereby you say that ensure the eye is perpendicular to the scale or pointer. So ini adalah terlalu vague. So how you are going to ensure? So yang ni tidak boleh diterima sebagai ways to overcome your parallax error. But then adalah lebih tepat sekiranya kita gunakan statement bawah ni. Okay. To ensure we doesn't have any parallax error, maybe we might use the microammeter which have mirror strip that placed below the scale. Then we have to make sure the pointer is coincide with the image of the pointer in the mirror strip. So bila dia coincide, barulah kita ambil reading. So waktu tu kita takkan wujud parallax error. Okay. Then class, if you notice you are doing measurings of time in this experiment, so there might be an error in recording the time taken arise from the human reaction mistake, whether we might be too immediate or too late in order to start, lap and stop the stopwatch. So how we are going to overcome this human reaction mistake, which occurs might be randomly. So we might have to take 3 to 5 times of measurements, and then we calculate the average time to improve the accuracy. Okay. Then if you notice that we are doing the connection with a lot of connecting wire, so when we use too many long connecting wire, this might increase the resistance in the circuit, and this will lead to the inaccurate reading of the time constant. Why? Because our time constant is RC. So if our R increases, then our time constant will increase. So how we are going to overcome this one? So we will prefer to use short and thick wire, or which have lower resistance, or we might use breadboard to set up the RC circuit. So we will minimize the using of too many connecting wire that can increase the resistance. So you might pause the video and then note down the errors that might occur in the experiment. So anda boleh catatkan error yang wujud ni dalam you punya report writing dan cara mengatasi. So catatkannya dalam report writing you supaya lain kali report writing you boleh dijadikan sebagai rujukan apabila anda prepare untuk ujian amalan nanti. So the last one will be the conclusions. Okay, so in your conclusions you have to answer the objective. So what is the objective of our experiment? Our objective is to determine the time constant for the RC circuit and the value of capacitance. So you have to note down or rewrite the value of time constant you obtain. So the time constant you obtain and the value of the C1 you obtain, and also the time constant when you connect two capacitor in parallel, how much is the value, and the effective capacitance when you connect two capacitors C1 and C2 in parallel, what is the value of effective capacitance you obtain.